Previously.
Right, so where we've got 2 chips gone, we could have 3. This could be just part of the problem. I'd like it to be the end of the problem because I just want to get this one edited and finished. Okay, there's no heatsink on the 7805. I'll only be able to turn it on for a second. There's still a problem. There is still a problem.
And now.
Okay, so I've got the heatsink on now. I can turn it on. Actually, a really good idea now would be to try the Steam Card Pro, because it might be getting further. Well, it's getting a bit further. Yeah, there's definitely something else happening there. We've made a difference. And it's probably worth having a look at the same address lines now. So that, yeah, it's still low. In fact, it's not even low. It's like 700 milliamps. It's doing something. 3, 4, 5. Yeah, something definitely going on there. So pin 1 of the CPU is connected to the same thing, that address line 11. But look, pin 39 should be showing activity. I could connect the other one up and show you this. In fact, you'll probably need to see it, won't you? Let's pin 39 of the CPU is doing that on the good one and this on the bad one. So what does that tell us? There's still something wrong. Where's pin 39 go on the schematic? Pin 39 is address 9, and that is pin 14 of IC4, next door neighbor. 14. Yeah. Okay, so we've probably got a bad 157 there as well. I think it's worth just popping that out. And I mean, we've investigated all of the other options. Does it go anywhere else? Pin 14. It also goes down to the ROM. We know the ROM's okay. It also goes to IC26 in the same way. Is that pin 14 as well? Yeah, it's pin 14 of IC. This is mirroring the same thing. So I'm going to lean. Well, we could do the resistance check again because it could be the other one. So pin 14 to ground on IC4, 16, yeah, is very, very low. That is completely shorted, less than an ohm. I'm not sure my leads are very well calibrated. Pin 14 on this one. Oh, so 0.3, and I mean, they're very close together. So leaning towards this one. I'm going to pull out IC26, which is a 74 LS157 as well. These 3 are, these 4 are LS157s. And this one is an LS00, 74 LS00, and this is a 74 LS32. They must be paired together, and these must be paired together. Okay. Could be wrong. It's possible. Could be the other one. Could just be me not getting a good connection, especially with that low resistance with them that close together. I'd expect it to... I'd expect there not to be very much difference in resistance between the 2 chips when they're that... If the fault is in this one, I'd expect to see very, very similar resistance in that one as well. But I'm going to take this one out and see where that leads us. Well, this one's fun. For multiple chips, I did say, and I've got a feeling that there's going to be even more. I reckon some of the memory has gone as well. Change one thing at a time. I'm just going to take this chip out, see if the short's gone, and then I'll look for shorts on the where I worked on the other one. BlueSky. Right, I'm going to go straight for the resistance test, actually. Pin 14. 1.6 ohms. Dead chip. Check it in here. Not found. That's dead as well. 157, please. Oh, 157. 74, 157. Right, stick a socket in. Is that going to be the last problem on this board? I think there's more to come. I think there's more chips broken on here. I don't know how many, but I think there are more. Okay. Plug that in. What does that do? Still broken. Wow. Where do we go from here? I'm just going to look for low resistance. I mean, that's not the best test in this instance, but it seems to be that the ones that have failed, the two that I found so far, have failed with a short to ground on one of the inputs or the outputs of the chip itself. So let's try and see. This is all mega ohms. I wouldn't expect 129k on 1, 2, 3, 4, 6, pin 6 of that chip. No, it's 80k on the other one. Right. 7 meg. They could have failed open as well. Oh, we've got another candidate, 1.1 or 1 ohm-ish. One ohm-ish on pin 14 of IC4. That should just be open line. But I'm going to check some of these other ones as well. 10 meg. Let's put this on BP mode because that'll be quicker. Yeah, look, 24 ohms on that one. 1, 2, 3, 4, 5. Nope, that should not. That one's faulty. That's the actual ground connection. Okay. That one's fine. So we've got 2 more chips here that are showing incorrect resistance readings, like they're shorted. And they are both of the other 74 LS 157s. I might run out of 157s. So let's get the desoldering station involved in this again, take out both of those chips and then see where we are again. Oh, has chips just fallen out of the board? I took the wrong one out, that's why. That's fallen out the board with a socket on it. All right, we'll have to put that back in. I took the wrong one out. I even marked it. That's why it came out so nice and easy. It's all right, I'll edit that out. No one will ever know, just us. What's been nice about this is that very often when I fix a computer, there's one fault. There's one thing that goes wrong, and you find that fault and you change that chip and you're done. And it's fine. It's nice. It's part of the journey, and I still appreciate the fact that I get to bring these things back to life, and I get to share that with everybody here. But every now and then you'll get one like this, which is more of a journey. I'm going to use hot air on these two just because I fancy it. That's literally all the hot air needed. I've already forgotten. I think it's this one was IC4. I did a self-test then, so let's turn that back on. Let it do its self-test. Right, okay, let's try now. Okay, not found. That one's dead. Not found. 4 dead LS157s. Could still be faults in these, and they might still be a problem. They might have failed open rather than failed with high resistance. But let's stick some sockets in, find some 74 LS157s from somewhere, and try again. Actually, I could just put IC4 back in and fire it up from that point. Oh no, let's put them both in. So my crazy thinking there was that without IC25 in, it would actually just act as a 16K board, because these 4 chips here are the ones that deal with the upper RAM. These 2 deal with the lower RAM. But no, I'm just going to go for it. I'm going to throw caution to the wind, solder all of these sockets in and that chip back in, and see what happens. Unless I run out of 157s, in which case I will just put that one back in. All right, let's get that soldered. All those all soldered. Just doing a pin in each corner first. Well, not in each corner, in 2 corners of each socket and chip. And then reflowing them whilst putting a little bit of pressure on the back. Not too much pressure, because you'll actually push the pin through if you give it a good shove before the solder is molten. There we go. Ooh. Just to make sure that they're all flat to the board. So that's 4 logic chips and the CPU that have been faulty on this so far. Definitely something catastrophic happened to this board. Don't think overvoltage. Like I say, the voltage regulator would have coped with up to 30 volts of input voltage, and for the most part it probably would have ended up failing due to heat, because it has to dissipate that extra voltage and only pass on 5 volts of it and lose the rest, and that little heatsink is not going to do the job for a long time. But I'm not sure. I think that 7805s have some form of incorrect polarity protection, but I could be wrong. I could be thinking of the more modern versions. So I don't know what happens if you put the wrong polarity in a 7805. Sure, it happens a lot because of the polarity of the power connector on a ZX Spectrum being non-standard, let's say. Non-standard now. I think it's more likely a short on the edge connector, sending 12 volts in somewhere it shouldn't go. And with all the problem areas being connected, that logic stands up. Oh my God, I'm hilarious. Right, let's find another one. Are there any more on here? I just spotted one straight away. 74157, another one. Oh, are they all in a group? Yes, found 3. How many do I need? Just 2, but let's keep 3 out just in case. Well, that one looks new. Right, let's try this one. Yep. Oh, it's a HC. That might not work. Is it HCT? No, it's just a HC. That might not work. I'm going to stick to LS chips. It might be fine, but yeah, LS157. That's the wrong way up. Yep, LS157. Let's put that HC away. Got some snaggly legs. What are the chances? No heatsink on the voltage regulator, so I can switch it on for a few seconds. Same problem. Wow, it's still going. I reckon all of the logic's gone, and probably a lot of the RAM. If they've gone, I mean, they're all going to be connected to. I'm amazed that the ULA survived this, actually. Ah, yay. What are we going to do? I don't know. I'm not sure what to do here. Whether to just take these out. This whole board could have just been wiped out. Do you know what? I am just going to take those two out, because all of the logic so far has died. So I think it's reasonable to say that these might be faulty as well. And even if I can't see anything on, say, a scope, that doesn't mean that there isn't a problem. I'm amazed the ROM survived, because that's connected to the same address lines. The CPU went, but the ROM survived. And obviously all the memory is connected to these address lines as well. Especially the, well, no, it's split between the upper and lower RAM now. So who knows? Okay, this is the LS32. Oh, that's okay. That one's all right. Oh, I've got a feeling it's the RAM now. Yeah, it's the RAM. Okay, this should give us a better chance, actually, of the Steam card working. So if I pop these back in, I am going to put them in sockets, just because it's sensible to do that, especially with this many faults hanging around. So I'm going to pop a couple of 14-pin sockets in there, and then put the Steam Card Pro in. And there's another reason that I'm going to leave these in sockets rather than solder them directly straight to the board. I mean, it's sensible to put them in sockets at this stage anyway, when you're doing a repair. You never want to see a board end up with sockets everywhere, but I've got a feeling this one is going to be one of those, but not just because my diagnostic skills aren't as good as they should be, but because there's going to be just loads of broken chips on this board. Okay, so I'm not going to put those back in for now, and I'm actually going to remove these two, IC25 and 26, so that I've taken the upper RAM out of the equation in the terms of logic being involved. That should mean that this functions, if it can function, as a 16K machine. So just this memory will be in play if I connect the Steam Card Pro up to it. I'm going to give it a quick test without the voltage regulator connected, just to see if it runs. No. Oh, it's still got the internal ROM selected. This is a tricky one. Okay, it's been a journey. It's now a few days later, and my workbench is obliterated. Lots has happened. I caught the flu, and my family caught the flu, and we've all been suffering. But we're feeling better now, and during my more lucid moments, I would sneak back out here to the workshop and give this a little poke and a prod. I took out a couple of memory chips, That's the only thing I've really changed on this since you last saw it. Now, it's doing some stuff, and I'm going to spoil the end of the video right now because I don't want to waste your time. I'm not going to do any more work to this. It is still broken, and I'm not going to try to fix it now in this video. I might come back to it at a later point if somebody comes up with a really, really good idea of why it isn't working, and I'm sure somebody will, and then I'll make it into a second video. So where we are now is this. If I turn it on, it does this. This is with the Steam Card Pro plugged in. But if I start resetting, it's not going to work. I'll keep resetting. And then eventually, after it's been on for a little while, oh, that's the NMI, I start to get a slightly better image, but with some corruption. If I keep resetting it, the corruption starts to disappear a little bit more until I get a perfect image. And if I keep resetting it and resetting it, and then I'll let it run. This time it's showing that all of the lower RAM, apart from one chip, is faulty. This is nonsense. If I keep resetting it, eventually it will test the lower RAM and it will test it's fine. And then it will test the upper RAM and test that that's fine. And then if I leave it and let it loop around to keep testing, if you leave the Retroleum diagnostic running, it will just keep testing it over and over and over again. It will just keep testing fine. So this time, everything's going to test okay. You can see that the lower RAM is tested good, and now the upper RAM is testing, and that's going to test good. The upper RAM always the upper RAM tests fine as soon as the lower RAM tests fine. I haven't seen any upper RAM faults. So I left this running for like an hour, just going over and over and over the tests, and it didn't skip a beat. It's a completely working system, as you can see there, as far as I know. But even now, or even after an hour, if I turn it off and then turn it back on again, oh, this time it's actually worked. But if I turn it off and wait for a second, just like that many seconds, and then turn it back on again, it doesn't work. Which points to a capacitor issue. But I have changed all of the electrolytic capacitors in here, and I've even very recently, because I thought, oh, it must be the reset cap is not working right, I've put a brand new one in there to replace the brand new one, and I've tested them both and they're fine. So there are the only other components that are part of that reset circuit are C26 up here, a ceramic capacitor, and R31 down here, a 220k resistor. They're fine. There's nothing wrong with those at all. What on earth is going on? So what I did was I thought, oh, maybe it's a heat related issue. So I grabbed my air duster, which if you put it upside down and spray it, it turns it into a freeze spray. And I would spray a chip and turn it off and turn it back on again, and it would show that same fault. And then I would use my hot air gun to heat it back up again, and it would stop being faulty if I kept resetting in exactly the same way as I've just showed you. It wasn't actually the heat or the cold that was causing a problem. It was just being switched off for a little while and then switched back on for a little while, and then you get corruption. And it only has to be a couple of seconds and it starts corrupting, but then if you start resetting, it'll go away. So it's got to be something that's holding a charge somewhere, but what it is, I could not tell you. I've changed the ROM again, and I've changed the CPU again, and I've changed the ULA again. I've changed the logic chips and removed all these other ones again. And like I said, I've already taken a couple of RAM chips out and they test fine. I've freeze sprayed all different areas of the board and heated them back up, and it doesn't seem to it seems to do the same thing wherever I freeze spray it. So I'm at a loss on this one. I think that there's either something that I'm missing, or it could be that a RAM chip that's left on here is failing in such a way that is dragging down, that is corrupting things on the first switch on until it warms up. So there might be like an edge case chip on one of these, but without taking them all out, I just won't know. I am kind of tempted to do that, but I don't know. I don't know. I don't think that it's. I think it's going to be more work, and I think the errors the faults that I found so far with, what was it? It's been quite a while now, so I've forgotten. Was it a bad CPU? I think I know that. No, I think the CPU was okay. It was 4 logic chips were bad. That was that was the thing that was definitely bad. And every time that it's still looping around now and it's still testing fine. But every time if I let it run off of a bad start, I have to wait a little bit longer because it's warmed up nicely now. It's got to be reset. Look, it's not. It won't turn on there. Black screen. If I reset, it just goes straight on. Now that it's warmed up, there's got to be something in the reset circuit. And the only the only thing left in the reset circuit is C26. I've tested it in circuit, and it looks exactly the same as the ones on the other boards next to it. Okay, I think because it's the last thing. It's the last thing I want to do on this board. If that ceramic capacitor tests okay, then I'm done. I've put quite a lot of work into this one, and I've got a lot of machines to fix. Okay, it's meant to be 47 nanofarad. I need to make sure that I'm not touching it. I don't think I'm going to be giving it that many farads. 73 nanofarad. Okay, so that has gone quite wildly out of spec. That's doubled. Let me get another one. Well, that took some finding. I really need to organise my stash better. My parts bins are, well, chaos, basically. So I found some brand new 473s. Let me just see if this 44 nanofarad, that is perfect. It's not the right package, but it's going to do. Oh, if this is it, I want this one to stand up off the board a bit because it's not got anything protecting it. Oh, please let this work. This would be so good if this works. Also bad. It's doing exactly the same thing in a slightly different way. The reset is probably a little bit better and cleaner than it was before. So look, I think what's happened here is this has taken a hit of possibly 12 volts or something, or a badly inserted edge connector has shorted out 12 volts onto a data line or an address line or something, and that's gone through and fried these 4 chips here. For some reason it didn't take these ones, but maybe these popped and protected these ones. It seemed to be the same pin on at least a couple of these. I'll have to test that. And maybe these taking that hit saved things further down the line. But there's a chance that that voltage ended up through some passives on here that have also suffered. Maybe that's why this reset cap is not as healthy as it should be. And maybe some of the other caps on here that are important to what's going on are suffering in a similar way. Look, I'm I am reluctant to walk away from this one, but like I say, there's only so much time I can put into each one of these machines to get a satisfying conclusion. I'm not going to throw this away. I'm not going to turn it into parts or anything, but I will put it to one side for now and work on something else, because that's often a really good way to reset your brain, and it will also give you an opportunity to give me your opinions in the comments if that's what you want to do. It's looping around perfectly now. So I don't like to do it, but I'm going to have to say at this point, this one's beaten me, especially after having beaten the flu. Yeah, this is not something that sits easy with me, but I could get stuck here for a long time and not be making any videos, which wouldn't be good for you or me. So let's call this one a day and move on to the next thing. Maybe I'll do a Commodore 64 next. You didn't think I was going to give up that easy, did you? No. Right. So I've been on a bit of a journey with this computer. A bit of a journey. Many things have happened. I took out all of the lower memory and I tested it with my trusty little 1-bit DRAM tester in 4116 mode, and it found 2 faulty chips. These 2 at the end here came up with a flash code on here. Now, when you test a chip normally, you know, it doesn't take that long. I'm going to show you. Right, one of these is good and one of these is not. Well, I say not. Okay, so this is one of the chips that tested good. And if I press that, the 4 little lights will eventually just go solid blue. That indicates that that chip is good. So we can pop that one back in the board. This one, I'm pretty sure, is one of the ones that didn't test good. Well, I say not good. It comes up with 4 flashing lights. And I've looked on the eBay listing where I bought this, which is where the instructions are in the listing, and it doesn't say anything about flashing. And that one, in other testers that I've got here that can test 4116 chips, tests good. In multiple other chip testers. This end one does a slightly different thing. It has just one half of it flashing. I don't know what that means. Anyway, they test good. I think that's going to be like a marginal thing. I did replace them and I tested it and it does exactly the same thing. I then took out all of the logic because I thought maybe it's something I've introduced, because the fault has slightly changed along the way, although I have fixed a lot of problems, which might mean that that fault was always going to change. But I wanted to eliminate the possibility that I'd done something wrong. So I took out all of the sockets for the logic and inspected under there, and I buzzed out every single trace and via and through hole, plating, everything. Perfect. I hadn't done anything wrong. Put back IC3 and IC4, which are the only chips that are needed for this to be a functioning machine. Without these installed, it completely ignores the lower RAM. So they're out of the picture, really. I did think, oh, and once I did that, it was fine. Sorry, it was still broken. I did think for a short while that the upper RAM might be involved in some way, so I did start to desolder it, and then I stopped. When this is warmed up, this machine passes its tests. It's a problem when it first starts, when it first switched on. Something changes over a period of time, a short period of time, a couple of minutes at most, that rectifies the problem, and then the machine functions. But then if you turn it off again and then back on again almost immediately, it will start to show the fault again. Now, everybody knows that that's capacitors. And I did even replace the reset cap, this 1 microfarad reset cap, with a brand new one. No change. I also replaced this cap here, which is part of the reset circuit, and that made no difference. So it's not the reset circuit. The reset looks fine. So what else could it be? Well, the 4116 chips here rely, and this is I'm sure this is where the problem is centered. All of the diagnostics that come back faulty point to IC3 and IC4 and the lower RAM. These work in conjunction with each other. These two are controlling the addressing of these chips. And if there's something wrong with these, it will show up as a lower RAM fault. And if there's something wrong with these, it can, especially if you lose all of them, the diagnostics will point at IC3 and IC4, which they are. Now, when the diagnostics shows the fault, it often, to start with, shows the fault across all of the chips. And then as the condition improves, then maybe 2 or 3 chips, and then 1 chip, and then no chips will be faulty. So that it's not actually a problem with the lower RAM. Oh, and by the way, with all of the logic installed, the upper RAM also passes. So I'm convinced that there isn't a problem with the upper RAM or the lower RAM. So what else could it be? Now, the lower RAM relies on 3 voltage rails. There's -5 volts, -5 volts, 12 volts and 5 volts. And the 12 and -5 volts are there as a bias voltage. So it's some way that I think is it CMOS transistors work inside these chips, that they need that to regulate the voltage. I don't know. I don't understand that part of the science, but I know that they are required, and they're required to be at certain levels, obviously, 12 and -5, but they're also to be certain quality. I haven't ever done this before. I've never had this fault before, so I didn't even think, and I know that people will have been screaming at the screen saying that this was, but I'm sure that people like Jim from Happy Little Diodes is going, it's the voltages. So I eventually thought I need to have a look at the voltages and find out what the quality of the voltages are like, because just using a multimeter to measure the level of the voltage is not a complete picture. Let's do that first so I can show you what's going on from that perspective. So we've got the -5 volts is -4.8-ish, which is perfect. It's completely acceptable. The 12 volts is 12.2. That's normally a high reading for this. The 12 volt rail on these is usually a little under 12 volts. Anyway, the 5 volt rail is 4.96. So at first glance, all of these are fine. No problem at all. But a multimeter only shows you an average voltage. An oscilloscope, on the other hand, shows you a bit more of a broader picture. Let's start with the 5 volts. And this is in AC coupling, so we're seeing a zoomed in scope, a zoomed in waveform for this, and that is actually quite acceptable. There's nothing wrong with that at all. It's a little, fuzzy, but that's okay. This is the -5 volts. Here we go. I'm not an expert with oscilloscopes by any means. I fumble my way through these things, and this is just me stumbling across settings that seem to show me the results that I want to see. So that's a -5 volts, and again, a little bit noisier, but not a problem. This is the 12 volts. Yep. So that reading is wrong. That's all over the place. There is something wrong with that. Now, the reason that we were getting a higher voltage, a higher average voltage, was because the spikes in that noise were actually pushing the average up. So that's what that is. But what could it be? There are all sorts of bits here that are involved in generating this this waveform, this voltage here. But from what my understanding, TR4 and TR5 are part of the voltage generation, the DC-DC conversion circuit, and they generate the -5 volts, the +12 volts. They're also a -12 volts, I think. They generate the -5 volts, 2 +12 volts. One goes to the video the LM1889N chip, and the plus 5 volts is generated directly off of the 7805 voltage regulator, which, by the way, I have changed. It was one of the first things I did because I thought, oh, that might be, you know, a noisy or malfunctioning voltage regulator might be causing a problem here. But there are other things involved. There are diodes here. I think D9, which is down here, is involved. There's another D15 is involved. There's another diode as well. I think D11, which I think, oh, that's D12. Might be that one. Let's get a schematic. Hot off the printer. Okay, so we've got the 5 volt coming in. This is the 7805, and yeah, it comes into TR5, and I have replaced TR4 and TR5 with brand new ones because they're an obvious target here. And the 12 volts coming out, I'm pretty sure that that one's the one to the voltage and this one is the one to the video, but that's oh, there's a minus 12 volts as well that comes out just to complicate things even more. I think that goes to the edge connector. Anyway, in between all of that are various components. Now, I'm pretty sure that we're safe up at this point because the minus 5 volt is working. It has no noise on it. So it must be something in this part of the circuit. So it's either going to be D15, R62, which is a 15 ohm resistor, and that is an electrolytic capacitor, and so is that. So it's not either of those because they're probably not either of those. They've been replaced. So my favorite choice of target here is D15, which is this diode directly underneath the keyboard connector. It could also be the coil. The coil is directly connected to that part, so it could still be the coil. Oh, that's interesting. I just messed around with the coil and it started making farting noises at me. I don't know. It might be. It could be the coil. But I would have thought that if the coil was bad, the minus 5 volts would be bad as well, because that's also generated from that same point. So I do think it's further along the chain. But maybe we can test that. That's all right. Okay, so I just touched the coil again and it crashed straight away. It's not doing it now though. Oh no, it did. Okay, I'm going to change the coil. That's not a difficult thing to change. I can pull one off of a salvage board. No, I don't think it's the coil. I think that coil's okay. No, it's exactly the same. So the next target on my list is D15. I also want to check R62, which should be 15 ohms. That one there. Bang on. So it's got to be, it's the last thing left. I do have another course of action. If I can't solve this 12 volt ripple for some reason, then I can actually replace all of the 4116 memory with 4164 memory, which doesn't require the other voltages, and just remove pin 1, and then I think you take out pin 8 and join it to pin 9, or the other way around. And that will act exactly the same, but be a bit more reliable. Oh, something else I did along the way is replace this diode here. That's part of the speaker generation. The speaker is now working, so something else I fixed. If it's not this, then I really am at a loss. No, it's doing the same thing. Exactly the same. And the 12-volt rail is still ridiculously noisy. Okay, so it's not the coil. It's not D15. But there are some other things going on here that I want to quickly explore that I found through my pokings and proddings. Now, the problem is all the way back at the supply. Okay, this is the output, sorry, the input. That's the output of the 7805 regulator. That's the input. But I can tell you that it's not my bench power supply. I'm going to show you my bench power supply now. So you have to cobble this together. Right, this is my bench power supply's power rail. It's just it's ridiculously clean. It's really, really clean. So the problem is something is being backwashed into that early part of this circuit. And I think it could be this capacitor here. I've poked around at some of the other ones, and this one is showing that a different value to a board I have here to compare it to. So using my little LCR meter here, I keep calling this a multimeter, but it's not. It is actually an LCR meter for measuring capacitors. So this is C43 here, this long boy here. Let me just have a look, see what value that says. I think it's 100 nanofarad capacitor. Oh, well, it says 100 nanofarad on the schematics here, 100 nanofarad. And if I'll measure this one first. This is a scrap board, but I'm pretty sure it's mostly functional. It's just missing a ULA, and I've just been pillaging parts off of it. And if I measure this one, I get 92 nanofarad, which is quite normal. 826 ohms ESR on it, but I'm sure that's fine. But on this one, and then they are both issue 3 boards. This one is saying 205 nanofarad and a similar reading on the resistance. So I'm going to pop that out. I'm actually going to just stick the one out of this in it. I'm sure I've got 100 nanofarad caps around, but I'm going to be impatient here. See what it does out of circuit. And just so you know, the workbench has very, very low capacitance, so it's not going to interfere in this reading. Oh, that's concerning. And it's moving because the capacitor is cooling down where it was just heated up. But that looks like it might be fine. So what was causing that extra capacitance in the circuit? Well, this is saying that this is a... Oh, no. No, there's nothing wrong with this. Right, just in case, I am going to change it with the other one. I don't expect that this is going to make any difference whatsoever, unless there's some other reason that that capacitor was out of spec. And no, it's doing exactly the same thing. What else could it be? I give up. I've never put as much work into trying to fix such a simple thing and still failed. And I think I know what might be wrong. I'm not a happy bunny at the moment. So let me tell you what I've done. from start to finish. Well, I'll try to remember everything because this has been such a long and involved process, but I'll try and point out everything that's been changed on this board. I've tested obviously the ROM, the CPU, the ULA, all of the lower RAM has been taken out and tested. All of the logic chips have been taken out and tested, and the ones that were broken changed. There was a faulty CPU as well in this. I haven't taken out the upper RAM because it's isolated. I don't think that's a problem. None of it's shorted. I don't think, and then looking at the traces on the scope, doesn't look like that's causing an issue. That is one thing that might be something to do in the future, maybe. It was obviously recapped, composite mod fitted, TR1 and TR2 have been changed. I've changed the voltage regulator and the power jack. I've swapped out the coil. I've changed TR4 and TR5. Oh, I've put TR7, a new TR, no, the diode above TR7 I've replaced. I've performed a DC-DC mod to it, so I've changed some components around here, this capacitor and a couple of resistors and things, and this little bit here with two BA157 diodes and electrolytic capacitor there, in an effort to solve this problem with the with voltage ripple on the, well, I thought it was only the 12-volt rail. It seems to change every time I poke it with anything or change anything on the board. Let me show you one more time. Okay, that's the 12-volt rail. Showing like a ripple of 3 or 4 volts. That's the 5-volt rail, which isn't too bad. Still a couple of volts of ripple there. And sorry, that was the -5 volt. This is the 5-volt rail, which is fine. I've done my best at... oh, there's something else to consider here as well. Is that these two capacitors down here, this one here is the 12-volt rail, and this is filtering the noise on the 12-volt rail. This is what this one does for the lower DRAM. And the left-hand side of it, the positive side of it, has this horrible noise on it, and the right-hand side is ground and shouldn't have anything on it. Now the one above it is the 12-volt that goes to the video chip, and that doesn't have any ripple on it at all. Nor does the left-hand side. Oh, just check that. Actually, the left-hand side is now showing some ripple where it wasn't before. And these caps are these two here, these 200 microfarad caps here. This is the 12-volt supply going to the DRAM, and this is the 12-volt supply going to the video chip. But I can go back to other parts of the circuit. I can even go back all the way to the left side of C50. C50 is this one, and that one has noise all over it as well. And the left side of C34 above it has a different sort of noise. Now, I don't know which ones of these are supposed to be there and which ones are not. I could get another spectrum out and compare them, but I've done that, and I've pulled every single component out of this board. Well, not every single component, but all of the resistors I've measured in circuit where I can and compared them with another working board, and they are all good. All of the capacitors have been removed and tested or replaced. All of the diodes, every single diode in this circuit, this one, this one, this one, this one, have been taken out and replaced, and in some cases added to, because this is now the issue 3B DC-DC circuit. The transistors have been replaced. The coil has been replaced. I've changed the coil as well. So I've honestly, really, I'm as disappointed as you. I don't like leaving a video like this. I'm not even sure how I'm going to edit this one, because I got to a point earlier on where I thought I'd exhausted all the possibilities, and then realised that I hadn't. Looked at the ripple and thought, well, that's got to be it. And I still think that that's it. But the circuit isn't working properly, despite the fact that I've changed and checked every single component on it. And the only thing that I can think of that might be causing that is there's a trace with some high resistance on it somewhere that is causing actually, when I gave the board a little twist then, and I had some interference on the screen. That could just be, no, it's not that. Every time I think I'm done with this thing, it gives me false hope. So look, I'm flexing the board and I'm getting inconsistent readings, inconsistent results. I think that this board at some point has suffered, whether it could be physical trauma or whether it's had some voltages put into it that it really doesn't want. Because, I mean, all of those LS157s, all those 74 LS157s that broke, all went bad to ground. They went high resistance and on one data line, or not one data line, on one leg. And that kind of lends itself to a bad voltage going through, traveling through that path. And it could have vaporized a trace somewhere or degraded a trace or something at some point. But I think that's the problem. I think there's a trace here somewhere that is faulty, but not to the point where I can detect it using continuity tests. It just seems to, everything I've tested seems to have good continuity. Look, I've given up probably 5 times, I think, on this, and I've not recorded every single one of those events. So you're not seeing the whole picture here. I have skipped over a few things, and I've done a lot of work off camera because this was one of those repairs that it was getting away from me, and I was losing heart that I would actually end up with a working machine at the end. I've recorded, I think at last count, 4 endings of this video. You might have seen some of them during the edit. I'm not sure which bits to leave in, but on my first rough edit pass of this, in fact, there's been a couple of rough edit passes of this, I've seen myself say, no, I've had enough. This is a machine that's just not going to be repaired. Now, partly this is partly my fault, but partly I just think it's the set of circumstances that came together with this particular machine, and those are this. The faults so far were a bad CPU, 4 bad LS157 logic chips here in IC26, IC25, IC3 and 4, and all of the RAM, as far as I'm aware, tests good, and everything else has been upgraded to what it should be. The electrolytic capacitors have been changed, the DC-DC mod has been done. I've replaced loads of components in the DC part of the circuit. I've replaced all of the components in the resets part of the circuit. I have done many things. At one point, I was convinced it was voltage ripple that was causing the problem. So I removed all of the lower RAM and I replaced it with this Spectrum's lower RAM board, which doesn't require the plus 12 and minus 5 volts and will run off of just 5 volts. I also started converting 4164 chips to be compatible with these 4116 chips, so you can put these straight into those sockets and they will work. It wasn't anything to do with that. I don't know whether the voltage ripple that I was seeing was a red herring, whether I was using the oscilloscope wrong. I'm sure people will only too happily correct me or tell me how I was doing something wrong, but I thought that was a reasonable thing to chase. I then went after the reset circuit with, changing everything in that part of the circuit and trying to find ways to make that work cleaner. I was convinced at one point that this resistor here, which is a 220k resistor, which I was measuring. I can show you this actually, it's quite funny. So I was measuring this resistor here like this and saying, oh, it's coming up as a 10k resistor, which makes you think, oh, it's either the wrong resistor has been put in there at factory, or maybe something along with these going bad has made that resistor go bad in the reset circuit. I don't know why that might be a thing. So I took it out and put another one in there, and I tested the one I took out, which tested at 220k, which isn't a perfect test, because if you're not putting more current than a multimeter can put through, it's a good test, but it's not the best test. It is still possible that that's a faulty resistor. I replaced it anyway, and it wasn't that. I then realised that with the Steam card plugged in, if you test that resistor now, it's 220k. So there must be a 10k resistor on there that is overcoming that circuit. Anyway, I took out all of the upper RAM just in case that was causing a problem, and all of the sockets for the logic chips here. I removed these two sockets as well and checked underneath those. I swapped out the CPU again. I then started looking at the clock. Now the clock looks okay. As far as I can tell on my oscilloscope, it looks fine. But there might be a microsecond at the start of when it starts up where the clock is not doing its full duty. It's not actually oscillating at the millisecond that the computer is switched on, which could affect things. And I looked at the components in that part of the circuit. Obviously the crystals I want to leave to the last thing. But there isn't very many components in that part of the circuit. There is just this capacitor here, which is 2 down from on this row from the modulator, which is I think a 15 picofarad capacitor. I've taken that out and measured it, and that is fine. And then I thought, well, look, the thing that's generating the clock goes in, or the crystal, the signal for the from I think it's X1, which is this crystal here, this 14 megahertz crystal, goes into the ULA via that capacitor, and that generates the clock for the rest of the computer. Maybe it could be this one. Now this isn't the ULA. This is the ULA. This is exactly the same as this ULA. I'm actually going to take this one out. Let's go back to where we were. Oh, by the way, this socket has been changed. Everything's been changed on this board. Right, let's put the original ULA back in here. Now, if I turn this on, yeah, we've got corruption. It's not working. Okay, but if I then reset it, keep resetting. That's actually a new. Okay, oh no, oh, here we go. Look, it's because I know why it was. It's because I was on a different test. So yeah, look, that's what we were seeing. So just a little bit of corruption, then it disappears, and then it'll pass its test. So actually that is an interesting point, because the other test, not the Retrolium test, the other test. I can't remember what it's called now. The other spectrum diagnostics fell over earlier than the Retrolium one, was more sensitive to this problem. That problem, look at it. If I reset, it goes away. Now, I had tested every single chip in this board has been tested in another ZX Spectrum and works fine. That's the test. That's the ultimate test for a chip. If you've got a suspected faulty chip, you take it out of the bad board and you put it into a known working board, and if it tests okay, that's a good chip. So let's do that. Take this suspected bad ULA out of here. This is a known working machine, although it's a different revision. The clock circuit on here is exactly the same as it is on every other revision. Actually, I can't see any differences in the components in that part of the circuit. So this should just work normally. Right, with that in, does this ULA work? Yes, it works first time perfectly. Well, the speaker's not working for some reason. Is that really not working, that speaker? Oh, that's interesting. The speaker's not working, but it's booting fine. I just need to know now if this is a problem with this ULA. This had a -7 in it, so I'm just going to put a -7 back in here. No, the sound's not working on this one. I still need to fix that. Right, so we know that this, now we've tested this in a working machine and it's working. We know it's a working ULA. So I should therefore pop this back in here and carry on with my diagnosis. But I thought, hang on a second, why don't I put a later revision ULA in here and see what that does? Oh, side note, I just spotted that I put the wrong ULA in this one. This is another -6, so that could be the sound problem, but I doubt it. But this should have a -7 in it. All right, that's working fine. So putting a -7 ULA in here, will that make a difference? Works fine, perfectly, first time. So maybe there's something more sensitive. There's a difference between these two ULAs that is causing a problem. Well, the only way to find that out is to use a -6, a different -6 ULA, and see if that works, which is what this is. This -6 is exactly the same as this one. Oh, 6C00IE-6. What about this one? That one works as well. All of this fault finding I've been doing has been because this ULA is faulty, but it's not very faulty. It actually works fine in a later revision Spectrum or another ZX Spectrum. I don't know why, what the difference is, but there is a difference, and that's what it is. That's what's happened. So I don't know what to do with this one now. I'm going to put it in one of my machines, I think, and use it and see, you know, it might still have a bit of life, but I think that whatever took out these logic chips also damaged this ULA slightly internally. But now I think it's time to put this one finally to bed. I came to this one expecting quite an easy repair. I think it started off just being a dodgy power socket. And look at the state of where we've got to. Still not sure whether I should just completely socket this one and keep this board and swap it with one of mine for Paul. Because this one would actually it wouldn't be a very reliable. I don't know, and I'm not sure how Paul feels about selling this one. He might have to make it clear in the listing that this machine, you know, put it with the video and everything so that people know what they're getting into. Yeah, I mean, maybe if we sell it with a different ULA, that would be okay. Anyway, look, this one's gone on way longer than it should, and I am going to be so happy to be moving on to repair something else tomorrow. And I'll be amazed if anyone has got to the end of this video. Leave a comment if you got to the end. Give me a wave and from the other side, and you will get extra internet points. I don't give those out very often. Anyway, thank you for watching. I really appreciate the kind support that I get from all of you lot. It's really just why I do this. Thank you very much. I'll see you in the next one. Yeah! I didn't lose. Sometimes you need to take a break and have a think about what you're doing. What am I missing? Am I going to end up taking all of the RAM out of this? This is a tricky one. Anyway, it's the way it goes. Sorry, I'll see you in the next one. We'll fix something in the next episode. God, this was a long one. I'm really, really sorry. Mark it up to experience and move on. Okay, I'm going to go and cry in my beer now. I give up. Thank you for watching. I'll see you in the next one. Oh, God, thank God that's done. I am donezo.